Okay, the answer to number 1 is B. I'll just tell you the answer here, and then we'll understand it going backwards. Roman numeral 2 totally works here. Roman numeral 2 is a compare to method that could indeed be typed and added into this fraction class. Right here where method's not shown, pretend that it has this compare to method. It does work. Things to point out, notice that you can call the double value method because you are in the class and you don't need something dot double value. It just calls double value on the current object, this object. Notice right here that you have to do this fraction in parentheses. That's called casting, and you do need to do that. Because other is passed into this method as an object from the object class, it needs to be upgraded and casted to the fraction object that it really is from some client program that passed it here. So that's just totally necessary, and this annoying extra set of parentheses is needed to override the built-in order of operations. And this method does return a positive number, a negative number, and a 0 in the necessary situations. It does not use particularly good style with curly braces and indentation, but it still works. So this is okay. It does work, and it could be used. Now, why does Roman numeral 1 not work? Well, I'll tell you, because this needs to be the word object with a capital O. When you implement and override the compare to method and type it out in a class like fraction, you must include the line of code, start with the line of code public int compare to parentheses object. This name can be anything you want. You could use X, or you could use the initials PG. You can do anything you want there, but object must be the data type. Even though you are in the fraction class, you must type the word object, otherwise you'll get a squiggly compile error. Okay, this might work or it might not work. I don't even care, because this would have, right here, this mistake would have ruled this out. Roman numeral 3, this is really tricky. To be honest with you, only like 10% of the people in the country would get this question right on the AP exam if it came down to Roman numeral 3, understanding it or not. Let's trace this quickly. Let's pretend that in a client program you had this fraction that was 2/3, and you wanted to do a dot compare to with a fraction that, in the parentheses here, this fraction object, I don't care what the name of it is, Nemo, Flick, X, Temp, but let's pretend that the fraction object that's being compared to 2/3 is a fraction object that has a numerator of 1 and a denominator of 2, so it's like 1/2. So if you did this, that means that 1/2 is being passed as a parameter to other. The 2/3 is really this object. So when you call double value here, which is really equivalent to typing out this dot double value, you're really referring to the 2/3. So what does double value do to the fraction 2/3? Let's take a stroll up here and look at the double value method. The double value method takes the numerator, which in this case would be 2, it doubles it, it typecasts it to a double, so that changes it to 2.0. The denominator of 2/3 is the number 3, and so when you have 2.0 divided by 3, that does indeed return the number 0.6666 repeating. I'll just change it to 0.667. So a 0.667 does indeed fill in this blank right here when double value is called. So far, so good. Now we have to unravel this mess. Well, other, we just agreed, is the fraction object 1/2. And for technical reasons that I'm not getting into right now, because 1/2 is passed in as an object, you must cast it to a fraction, otherwise you get all kinds of errors. So that is just necessary. So now when we have 1/2 and we do a dot double value, what happens? Well, as I explained a second ago, the 1 changes to 1.0, and 1.0 divided by 2 is 0.5. So all of this is now simply 0.5. And we're left with 0.667 minus 0.5. And that difference is 0.167. I can do that in my head. So we now have to analyze this. the word int here in parentheses. If you remember, that's an example of typecasting, which means chop off the decimal places. What? We're left with just 0? We are returning the number 0 back to some client programmer when we subtract 2/3 minus 1/2. We didn't subtract, we really did a compare to. Well, when we compare 2 and we get a 0, that means that two things are equal. So we just analyzed this and we just determined that 2/3 is equal to 1/2 because this method just returned a 0. That's baloney. Roman numeral 3 does not work. That rules out E and that rules out D, by the way. And we've already ruled out 1, so the answer is B. Now this was ingenious. This was an ingenious attempt to do some subtraction to see if one fraction was greater or less than another fraction. But because of this int, this overzealous typecasting, it ruined the whole problem. Oh, I see why the person put int there, because according to the rules of compare to, you must return an int. You're not allowed to return a double. So in their effort to make this into an int, they chopped off the 0.167 that they actually needed to show that this object was greater than the parameter object, and therefore it should have returned a positive value. But sorry, this is just not a legal way of doing it. Roman numeral 2 is the only way to have pulled this off. Question number 2 in this worksheet, the answer is E. This code segment causes a runtime error. Now you're assuming that you're in a client program. In other words, you're in a public static void main string args somewhere. So if you're in the curly braces for some main method and this code appears in there, can you do this or not? Well, let's trace this to see why it's a runtime error. You are allowed to do this first line of code. We haven't studied this yet this school year unless you really read the Unit 9 lecture notes very, 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 very closely. But I'm hereby telling you now that this is legal. You can create an integer object like this. You could also just do it by typing equals 123, but that's not applicable here. This is another way of doing it. But normally you see over here the word integer. When you instantiate an integer object, you would declare it as an integer object with the word integer here on the left. But you don't have to do that. If you want to use the word comparable, that's fine, because I tell you this. The class integer that's built into Java does indeed implement the comparable interface. And anytime a class like integer, string, double, anytime a class implements comparable, you are allowed to declare it as a comparable, even though deep down you're calling a constructor from the specific class. Now, why you would want to do this, I don't want to explain right now. But this is legal, so this first line of code does not cause a syntax error. C is not an answer to this, even though you might have thought that until now, but I'm now telling you it's not. Okay, line number 2. Line number 2 actually is not a syntax error. It's a runtime crash. The program does not squiggly underline in Eclipse, but rather when you execute this code, it crashes, and that's called an exception error. Well, here's the problem. You have a string 1, 2, 3 in the parentheses of compare to, but x is really equivalent to just the number 123. It's an integer object, which in a sense is like an int. It's something without quotes around it, like you might have remembered me teaching in Visual Basic. Can you compare the zip code 19610 in double quotes with the actual number in Mr. Zeckman's math class, 19,610? Can you really compare those two things? Philosophically, no. And therefore in Java, this is a crash and it causes E. Now don't be fooled by Visual Basic, because Visual Basic would probably fix this for you and not crash the computer. But Visual Basic is like your mom or dad, or your average hotel maid. Visual Basic makes your bed for you. It doesn't make you do all this work yourself. In Java, you must do things like casting. And if we casted here, we might have been able to salvage the situation, or maybe not That's a question for another day. Okay, question number 3 on this worksheet. Hey, let's look at this question, number 3 here on this worksheet. That's just really super easy. That's D. You could have a class like public class Mr. Yo. And Mr. Yo, we'll just pretend that he extends, that class extends like Spartan. So anything that a Spartan is, a Mr. Yo is, plus more. Now, the important part I wanted to make is, I don't have room here, so let's just pretend I'm continuing. You can then type implements, and you can implement as many interfaces as you want. Comparable, swaggable, lovable, squeezable, all the ables you want. Hunkable, like a Mr. Yo is considered a hunk to women that care about that sort of thing. Intelligible, we'll say intellectual. That would be a good one. Chessable, somebody who's really good at chess. Now, what does all this get you? Well, it gets you one very well-rounded class, one well-rounded object. If you had an object declared in your public static void main like Mr. Yo, Peter equals new Mr. Yo, that means that in that class, he has the compare to method available to him. .swag is a method he could call. .love me would be a method that he could call. I am a hunk method. I am smart and get 5s on the AP exams. I win at chess all the time. Like, he would have every method available to him. So as many as it needs. Client programmers love classes that implement lots of interfaces. As long as you use a comma here, you can do as many as you want. Now, I will make a note. We will soon learn that when it comes to extending something, you can only have one class here, though. You can't put commas after the word extends. And you always put extends first and then implements if both apply. Okay, number 4, that's just wrong. That's just illegal. 4 is A. It's the opposite way around. You can't have a class, you can't have an interface implement a class. You can only have a class implement an interface. Trick question. Number 5. Well, I always scan all the answers to a question like this first. I don't plow into Roman numeral 1 and sweat it out. I skim all the Roman numerals. And I see Roman numeral 3 is like a fact. That's like the basic fact about implementing an interface. When you implement an interface such as comparable, you must type out and implement the compare to method in that given class. So Roman numeral 3 is by definition what you must do. It is definitely true. So guess what? That rules out answers A, B, and D, and E. Just by kind of reading the answers backwards and going with something that you should know, Roman numeral 3, even if you don't understand what 1 is asking about or 2 is asking about, because of the way they built the answers here, you can rule out all the answers, except for this one. I love it when test questions are made easy by just raw logic. Okay, number 6, students have argued this one with me before, but I did find it somewhere as another person's question, so let's take a look at it real quickly. It's fair game on an AP exam. Number 6, which is the least suitable candidate? Well, the answer is A. With names, there is an obvious way to compare two names, by last name alphabetically. With cars, there's an obvious way to compare two car objects, by price. Or you could compare them by year, like antiques versus cars that are not antiques. Or by model number. You could say, my Mercedes 300 is better than your Mercedes 100 because my number 300 is better than 100, bigger. So there are plenty of ways to compare cars, and there are plenty of ways to compare names. You could even compare names by length. And students. Obviously, you can compare students by GPA because that's what we call class rank. Or you could go alphabetically by students' last names. But is there really any clear, suitable, perfect way to compare 2 points on the Cartesian plane? The point 3, 1 compared to the point 1, 3 They're both equidistant from the origin if you want to go by distance. But this guy has a 3 in the y column, and this guy has a 3 in the x. Like, there's no, are they equal, really? But this guy's like closer to the moon. This guy's closer to the ground. Like, there's no clear way. So A is actually the answer because it is least suitable. You would not want to do implements comparable because it wouldn't be really clear to client programmers how that would be working. So you wouldn't probably write implements comparable. And moving on to number 7 on this worksheet. Very, very, very tricky question, number 7. I'm going to work backwards and just analyze it that way. Can you do this with temperature here on the left and temperature on the right? You sure can. This is okay. This does work. And if you trace the min3 method up above and pass these as parameters, it does work. And it does figure out which temperature is the lowest. Now, question number 2. That is legal too, even though we haven't really studied it. You have to have the word temperature here because the constructor that you're calling, the other constructor with 2 parameters, is found up above in the temperature class. Let's just take a trip up here to verify. In the temperature class, there is indeed a constructor that takes a string and a double, what we call a other constructor in Mr. Minix classes. So this is legal code right here on the right-hand side of these equal symbols. This is all legal. But can you put the word comparable here? Well, I told you earlier in this video that you can do that. Only because the temperature class does indeed implement comparable. Because of that, presence of that phrase there in the public class temperature class header, you can, if you want to, put the word comparable here instead of the word temperature. Now, why you would do that, I haven't taught yet in this course. But just trust me, there are times when, being Superman deep down, because I am Superman, I sometimes act as a mortal man. So I dumb myself down as Clark Kent. So it's kind of like having Clark Kent and then Minnick equals new Superman. There are times when deep down, even though I'm Superman and I can't change that, so I was constructed at birth with the Superman constructor, but I act like Clark Kent in public. I declare myself to be Clark Kent, even though below that drab clothing, I have the S on my chest, and I do have Superman powers. So later in the next unit, we will study why you would do this sort of thing. And Roman numeral 3, that just plain doesn't work. There is no comparable class. There is no comparable class that has a other constructor that takes 2 parameters. You can't put the name of an interface after the word new here on the right-hand side of the equal symbol. That's just illegal, so 3 doesn't work. So the answer apparently is Roman numerals 1 and 2 both work, and therefore the answer to this one is B. And finally, number 8. This is really, really tricky. But the answer to number 8, just for the record, in case I don't have time in the video to explain this, is D. The answer is D. The code will compile. However, if the class person doesn't have the play method typed out inside of it, it will bomb. Because person implements employee and musician, specifically musician, that means it needs to have this play method in here because the play method is the one and only method in the musician interface. Therefore, that has to be there. If this method weren't here, none of this code would work. Now, by the way, because it implements employee, it does need raise salary to be typed out. But that fact doesn't help you with any of the answers, A, B, C, or D, or E. So D is the only one that is a true statement. I could, with enough time, rule out A, B, C, and E. And I have 1 minute left in the video, so I'll try to do that. A, the code will not compile because person tries to implement 2 interfaces at once. No, that's legal. It's perfectly legal. You can have as many interfaces as you want implemented. B, the code will not compile because person has no properties. No, there's no rule that says a class has to have one or more properties, also known as instance variables. So that's wrong. Whoa, sorry about that. Shift in the video. So A and B are both wrong. C, the code won't compile because person only has methods defined in interfaces. No, that's not wrong. In other words, person has none of its own interesting methods typed out. Well, that's just boring, that's all. But that doesn't mean that it doesn't compile. And E, the code will compile. No, it won't compile because D, oh wait, no, the code does compile actually. Furthermore, even if class did not, oh no, it does need to have the play method typed out. So, oh, it would not compile if it had, so E is the opposite of D, so that rules that out. D is the final answer, and thank you, and have a good day.